Today, on how it's made. Baseball gloves. Medical electrodes. And Stetson hats. A baseball glove is an extraordinary thing. Each and every one starts out brand spanking new and ends up fitting its owner like a second skin. Before long, the player and his glove are inseparable. The glove helps him live his dreams and fills his imagination with lifelong memories. Baseball gloves have evolved from hard leather mitts to the sophisticated design players depend on today. It all starts with a hydraulic press that punches out the felt padding that will cushion the fingers and thumb. The holes will be used to lace the glove. Another press cuts out the palm section of the glove from a side of leather. The palm section also has lacing holes cut into it. The press then cuts out the web or pocket of the glove, preparing it for lacing as well. Meanwhile, a machine heat embosses the palm section with the company logo. Embossing also helps identify different leathers and glove styles. Another worker hand weaves the front and back pieces of the pocket. This special basket weave web gives the glove additional flexibility and control. Pockets first appeared in gloves in the 1930s. She stitches the pocket together. Then she applies glue to secure the tail ends, closes the flap, and stitches the web shut. Another worker then sews the palm lining and the finger lining together. By stitching the palm and finger linings together, she completes the interior piece of the glove that touches a player's hand. She then sews the felt finger pads to the lining. These pads give the glove extra comfort and control. To build the outer shell of the glove, she sews welting leather between the fingers. This makes the seams stronger. Then she sews the fingers and the palm piece together to complete the back part of the outer shell. Some leather softener helps prevent tearing as she stitches the back and the front parts of the outer shell together. She also uses welting leather to add strength and rigidity to the outer shell. A worker mounts the finished outer shell onto a finger form heated to about 120 degrees Celsius. It takes heat and leather softener to allow the worker to manipulate the shell without damaging the leather. The worker then transfers the softened outer shell onto a stationary turning stick in order to turn the outer shell inside out. He works the outer shell one finger at a time so he doesn't spoil the leather or the stitching. He makes sure all is perfect. Another worker slips the interior lining onto a mounting support, then covers the lining with the outer shell. He works the leather to make sure the lining and the shell fit together properly. Then he applies a special paste that makes the palm more flexible. He inserts a felt pad into the thumb. Then another cushioning pad into the pinky finger, using a metal rod to fully insert both pads. He then starts lacing the glove with a long strip of leather. Lacing the glove is a labor-intensive skill that can take up to an hour. No machine can do this. He makes sure the lacing gets the right tension, and the attractive side of the leather faces upwards. Using special knots and loops, he laces the entire glove by hand. A worker inserts wooden dowels and mounts the glove on more hot fingers to open up the fingers and thumb. This helps the player's hand fit into the glove more easily. Now this truly looks and fits like a glove. Today's baseball gloves come in all different colors and styles. They are so finely handcrafted, they could be called works of art. Medical electrodes can help your doctor find out what's going on with your health in a heartbeat. These little sensors detect electrical currents in the heart, brain, and other parts of the body, and they're wired to monitoring equipment that records it. They're inexpensive, disposable, and essential to healthcare. When the nurse says this won't hurt a bit, you can trust her if the test she's about to give you involves medical electrodes. These electrodes stick to the skin and probe beneath the surface without actually piercing it. They send information to monitoring equipment so specialists can assess it. These electrodes start with a roll of foam. The foam is coated with medical-grade adhesive and has a paper backing to keep the layers from sticking together. Machinery pulls the foam over a punch cutter, which makes small holes in it. Razors slit the paper, and equipment pulls it away from the foam to expose the adhesive. The process leaves strips of paper along the edge. The foam moves forward, sticky side up, as plastic elements and metal snaps cascade into a feeder system. They're queuing up to be installed in the holes punched in the foam earlier. Vacuum heads pick up the elements and insert them into those holes. The elements are coated with silver chloride, which makes them electrically conductive, so they'll help pick up electrical activity in the body. Next, pneumatic equipment press-fits the metal snaps onto the elements. These snaps are also electrically conductive. Down the line, a blade slices through gel that's sandwiched between two thin plastic liners. Machinery pulls those liners away from the gel. This gel is water-based and contains salt, which will seep into the skin to help establish electrical contact. Another blade cuts the gel into small rectangles, and they land on a thicker plastic liner. The gelled liner and foam with its elements and snaps come together, and the gels land directly on the elements. Rollers press everything together in a tight sandwich. Equipment pushes that sandwich forward into a cutting station. That's protective padding you see around the cutters. It protects the blades from the adhesive on the foam as they punch out electrode shapes. Blades now lightly perforate the plastic liner around the electrodes, while below, equipment pulls away the scrap. The perforations will allow the electrodes to be torn into individual units later, and it also makes it easier to fold up for packaging. Remember that paper left along the edge of the foam early on? It serves as pull tabs on some of the electrodes. The tab makes it easier to apply the electrode to the patient and then remove it. They package the electrodes in a special material made of plastic, aluminum, and paper. Hot metal plates melt and seal the material to form an airtight pouch. Finally, a long blade cuts the pouches into individual units. It has taken less than a minute to make this package of medical electrodes. They'll use many of them in just one test. With the gel side of the electrode pressed against the skin, they wire it to monitoring equipment. And within minutes, these electrodes can signal problems, and that could save a life. After the test, the electrodes will be discarded. Disposable and yet indispensable in the world of medicine. The cowboy hat was made popular in 1865 by the Stetson Hat Company and its founder, John B. Stetson. Part of its attractiveness in the American Old West was the wide brim that protected the cowboy from the elements, a high crown that kept a pocket of warm air on his head, and the ability to carry water if he needed to. All models of Stetson hats are made from blends of pre-treated fur, including beaver, rabbit, and wild hare. First, a worker gathers the mixture of different fur and deposits it into a picker machine that begins blending the fur together. The picker roller, which dates from the 1890s, sends the fur into a mixer. Inside the mixer, compressed air blows the fur around. This settles and removes any dust and dirt that may be trapped in the fur. After about an hour, the blended fur settles into a collection box. A worker puts it through a rotating loader machine that sends the fur into a multi-chambered blower. A look inside the blower reveals a series of picker rollers. These rollers, along with blowing air, allow the lighter fur to float through the chambers while the heavier hair and the impurities fall to the bottom. At the back of the blower, the worker gathers and weighs the amount of fur needed to make just one hat. That amount varies depending on the size and style. The proper amount of fur then moves by conveyor belt into a forming machine. Here, a vacuum sucks the fur onto a cone form. The fur builds up like a fragile blanket of dust that must be held down by a wet cotton mesh. For extra protection, a worker wraps burlap onto the cone and puts a metal cover over it. He weighs it down and gives the fur cone a good soaking in a vat of hot soapy water to make the fur fibers curl up and lock together. Shortly after, the worker peels the newly formed felted fur blanket off the cone. At this stage, the interlocked fur fibers are still very fragile, so a worker protects the cones from damage by wrapping them in cloth. Then she puts them through a hardening process, which consists of a series of massaging rollers and hot water baths. The rollers and the hot water baths increasingly shrink and tighten the fur fibers together. The final and most aggressive massage makes the fibers felt together even tighter, and the cone is now strong enough to manipulate by hand. But the cones must be even stronger than this, so she puts them through a final hardening stage that shrinks and tightens the fur fibers to the maximum. At last, the fragile cone that came out of the forming machine becomes the desired hat size. Tearing the felt by hand is now impossible. After the cones are dyed, they're placed on a crown machine. Here, he works the top of the cone and makes the felt more flexible. Another machine softens the brim. Together, the machines form the cone into more of a hat shape. After soaking the cone again, a worker puts it on a wet blocker machine. Its brass fingers secure and stretch out the felt, while it forces a crown shape into the hat body. Then he puts the hat body into a hat sucker or vacuum that sucks out most of the water. He then sets the hat bodies aside to dry for 24 hours. Up next, we'll see how these hat bodies are transformed into classic Stetson hats. Making a Stetson hat takes almost as much work now as it did in the early 1900s. Every hat made is still handled from start to finish by hand. Even some of the machines used are the same as in the past. The Stetson hat is an icon of the American cowboy lifestyle. A worker steams a hat body to make it supple. He puts it into a blocker machine with brass fingers that secure it in place. He steams it again, then inserts a wooden block and presses it into the crown. This gives the hat a specific head size. He puts another hat into the blocker, this time making another hat size. This is called blocking a hat. Blocking transforms the brim diameter and the crown from an almost shapeless cut of felt into a more solid body and precise hat size. A worker puts the blocked hat on a brim stiffener, which applies shellac. This shellac gives the brim extra firmness, making it easier to shape and style. He completes the brim stiffening operation and readies the correct number of hats to fill an order. A worker hangs up the hats for a natural air dry. 2 days later, a worker inserts blocks into the hat, which are color-coded for size. The blocks fit the hat on a pouncing machine that gently spins and sands the felt. This unsanded felt gets buffed until the hat ends up with the smoothest finish possible. Then a worker puts the hat onto a hydraulic crown press. Inside it, he places a piece of ink transfer paper and a heated aluminum mold. He lowers the press and applies the exact amount of pressure needed to mold a specific shape into the crown. On this particular hat, the press imprints the logo inside. Now the crown has a distinct shape. A worker then puts the hat on a brim cutter and holds it down flat with a cutting guide. She cuts the brim to the required dimension and removes the excess felt and the guide. A worker then puts the hat into a brim flanger, an aluminum mold that heats and shapes the brim. He then puts the hat onto an identical wooden shape and covers it to keep its form while cooling. Once cooled, this hat will keep its symmetrical curves that make it so distinctively Western. A worker then marks the center of the hat. She lines up a leather sweatband with the chalk mark and sews it in along the bottom edge of the crown. She then folds the sweatband in and makes sure the hat is perfect. She ties a classic ribbon band into a knot and secures it around the outside of the hat. She trims the ribbon to the appropriate size, which completes the work on the exterior of the hat. Then another worker puts it into a holder and peels up the sweatband. She places a lining inside the hat, applying drops of glue all the way around to keep it in place. She then puts the hat inside a box for shipping anywhere in the world. Authentic Stetson hats. Looking good, partner.